Welcome back to our educational journey through the fascinating world of antibiotics. In today's video, we will delve into the different classes of antibiotics and explore their mechanisms of action. So, without further ado, let's get started. Antibiotics, the remarkable medications that revolutionized modern medicine, have been saving countless lives for decades. These powerful compounds fight against bacterial infections by targeting specific vulnerabilities within the bacterial cells. Let's dive into the mechanisms of action behind some of these life-saving drugs. Our first stop takes us to the cell membrane and cell wall inhibitors. These antibiotics disrupt the crucial integrity of the bacterial cell wall, rendering it weak and susceptible to destruction. By compromising this vital protective barrier, antibiotics such as penicillin and cephalosporins deliver a crippling blow to bacteria, ultimately leading to their demise. Moving on to our next class of antibiotics, we find ourselves exploring the realm of DNA-RNA synthesis inhibitors. Within the intricate machinery of bacterial cells, DNA and RNA play pivotal roles in reproduction and protein synthesis. Antibiotics like quinolones and rifampin interfere with these processes, disrupting the bacteria's ability to replicate and multiply. This disruption proves to be lethal for the bacterial population. Our journey now takes us to the mesmerizing world of protein synthesis inhibitors. Here, antibiotics such as tetracyclines, macrolides, and aminoglycosides act as formidable gatekeepers, preventing the bacteria from creating vital proteins necessary for their survival. By interrupting this fundamental process, these antibiotics bring the bacterial cell to a grinding halt, unable to sustain itself and eventually succumbing to defeat. Finally, we arrive at our last destination, the inhibitors of folic acid synthesis. Folic acid is an essential component for bacterial growth and reproduction. Antibiotics like sulfonamides and trimethoprim impede the synthesis of folic acid, depriving the bacteria of this critical nutrient. As a result, the bacterial population dwindles, unable to replenish their supplies and ultimately meet their demise. And there you have it, a brief glimpse into the diverse arsenal of antibiotics and their mechanisms of action. Remember, antibiotics are powerful tools in combating bacterial infections, but their misuse and overuse can lead to antibiotic resistance, posing a significant threat to public health. So, let's use these life-saving drugs responsibly. Thank you for joining us today. Be sure to subscribe to our channel for more captivating content.